All right, let's talk about a color, but not just any color. We are going way back to resurrect a color so legendary, so exclusive, that it was, and I mean this literally, worth more than gold. We're talking about Tyrian purple. This was the color of emperors, a secret recipe that was completely lost to time. We're going to see what happens when ancient alchemy smashes right into modern artificial intelligence to solve a mystery thousands of years in the making.
So, here's the big question, right? How in the world did the ancient Phoenicians take a gooey secretion from a pretty ordinary sea snail and turn it into the most prestigious dye in the entire world? It's a question that, honestly, has stumped historians and scientists for centuries.
And look, we're not just talking about a forgotten technique here. The entire industrial process, it just vanished after the Roman Empire fell. The knowledge, the chemistry, the art of it, all of it, just gone. A secret completely lost for millennia, just waiting for someone or something to find it again.
Okay, so first things first. To really get this, we need to understand the incredible prestige behind this color. This was never, ever just about looking good. It was a loud and clear statement of ultimate power.
Exactly. To wear Tyrian purple was to wear your status for everyone to see. Roman senators, they had a purple stripe on their togas. But emperors? Oh, they wore robes of solid purple. It was a symbol of divine right, of immense, almost unimaginable wealth. And the sheer value of this color is precisely why its loss was so huge. But how do you even begin to rediscover something when the recipe has totally vanished?
Well, the journey to rediscovery didn't start with some ancient scroll in a library. No, it started with forensic clues left behind in the dust, turning this ancient legend into a full-blown modern investigation.
I want you to imagine you're a detective, but your crime scene is thousands of years old. The only evidence left? Microscopic traces of chemicals found scraped from the bottom of ancient dyeing vats in the city of Tyre. That is it. A faint chemical fingerprint was all that was left of a massive industrial operation.
So this residue, what is it really? Well, you can think of it like the ghost of a chemical reaction. These tiny, preserved traces can tell us what substances were used and, crucially, what processes might have taken place. It's the key that connects the physical thing, the vat, to the lost chemistry that happened inside it.
But okay, a faint trace is not a recipe. So how do you get from a tiny chemical fingerprint to a full-on industrial process? The answer, incredibly, lies in some very modern technology.
And this is where things get really cool. Generative simulations. Think of it like a digital chemistry lab on steroids. Scientists fed the AI all the data they got from that archaeological residue, and then the AI just went to work. It ran millions of virtual experiments, testing every possible combination of ingredients and conditions until, bam, it found a process that produced the exact chemical fingerprint they had discovered.
And this right here, this is the breakthrough. This technology basically let researchers travel back in time. They could digitally reconstruct the entire process, right down to what was described as the pungent vat-deep chemistry that defined the workshops of ancient Tyre. They could finally see the recipe.
So what did they find? What was this chemical secret that the snails held, the one the Phoenicians had completely mastered?
First, let's just take a second to talk about the scale of this. This number is just staggering. To produce a mere 1.5 grams of pure dye, that's just enough for the trim on a single toga, you would need to harvest 12,000 Murex snails. This was not some small-time artisan craft. This was an industrial operation on a truly massive scale.
And here it is, the resurrected recipe. The process kicks off with a milky fluid from the snail's gland. This secretion then ferments in these huge vats, a famously stinky process, by the way, that was the signature smell of the dyeing districts. But the real magic, the true aha moment, happens when that liquid gets exposed to sunlight and air. And just like that, a brilliant, color-fast imperial violet emerges from this murky liquid. It's a four-step molecular dance from snail to symbol.
So what's the bigger picture here? I mean, this whole rediscovery isn't just about a color. It's about bridging the gap between two completely different ways of understanding the world around us.
You have to remember, the Phoenicians didn't have molecular science. They didn't have beakers and charts. They operated on what you might call alchemical intuition. They didn't know about biological pathways. They knew the process by its look, its feel, and, especially its incredibly pungent smell. It was a science of the senses.
And this just puts it all into perspective so perfectly.
On one side, you've got the ancient artisan, following their senses, the smell, the feel, watching for that color to finally bloom. And on the other side, you've got our modern scientists mapping that exact same process with incredible precision, tracing every single molecular transition. It's like two different languages describing the exact same reality.
Yeah, this quote from the research team, it just says it all. The generative simulations didn't just find a recipe. They translated the lost language of ancient intuition into the modern language of biological reality. They connected two worlds across thousands of years.
And that leaves us with a really fascinating final thought. We managed to unlock the secret of imperial purple from nothing more than some chemical dust. So it really makes you wonder, what other lost technologies, what ancient medicines, what forgotten knowledge is still out there, just waiting in the residue for a new generation of tools to bring it all back to light?